Yeah, no. So first, data pipelines. Many people use this phrase to mean a complete integrated pathway from some source data all the way to the tools used by the business person. I see that your use of the term is less focused on that full soup to nuts pathway, but rather the possibility of shorter pipelines between, say, different components like an SAP instance and a website clickstream to an enterprise data warehouse. I believe this is a better approach and one that's more likely to succeed. Secondly, there is the question of what we mean when we say data warehouse, because there are many contrasting approaches. So in most cases, when I say data warehouse, I mean a two-layer structure consisting of an enterprise data warehouse, an EDW, in a loosely third normal form, or more likely today, data vault model, feeding multiple data marts, many of which may be dimensional in nature. And this doesn't exclude other structures, most of which are simplifications of this two-layer approach. And I'm going to limit myself to three, but there are many more. So first up, I'd say easy to use comprehensive tooling and automation. And that's fairly obvious, I think. Data prep is the most exacting and expensive part of a data warehouse. So setting up teams of programmers to build multiple, inconsistent, and unmaintainable bespoke solutions is, or maybe should be, a thing of the past. So that's point one. Best practice two, I think, is get the design phase right by involving the business closely and continuously in the process. This means iterative, agile development approaches, but less on the delivery of business apps, but more on the delivery of useful parts of the data warehouse information scope. And thirdly, I'd say maintenance and change management. These are key features that are often neglected. So focus on ensuring that upgrades and maintenance are considered early and put a process in place that is closely linked to the initial design and build. Key to this continuity brings me back to my first point. Tooling and automation play a central role in making this happen. So there's three best practices that I think are really important in this area. So in the old days, ETL was all from operational systems, often old-fashioned in design, with many arcane codes and field reuse and so on. And understanding these complexities, as well as deep business rules, some of which were obsolete, but were still in the systems, was a key requirement for an ETL programmer. And then there was the absolute demand to limit impact on the operational systems, both their design and performance. ETL engineers had to be deeply expert in the mysterious structures and content of these legacy source systems. The good news now is, I think, that operational systems are often better designed, more modern, and sometimes cloud-based. So there's less need to deal with archaic systems and more focus on innovative design and target systems. Of course, this brings down the cost and complexity of data preparation. However, I think external data sources like the Internet of Things do drive new needs, both in terms of timeliness of data and the types of analytics involved. So on the technical side, I think we also have to consider streaming versus batch load or replication approaches. Less archaic sources also enable a shift from bespoke, hand-coded transformations to more of a model or metadata-driven approach to information preparation, which is really at the heart of data warehouse automation. The order or location of the steps is less important to me than how we actually perform them, hopefully in some metadata-driven way. So it's worth noting as well that transformation is the most complex and important step of the process, and understanding where it happens turns out to be a key design consideration. So that said, and back to your question, ELT, extract, load, transform, simply means the transformation occurs in the target environment using the computing power and computational approaches, such as a relational database found there. Is that good? Yeah, mostly. Transforming on the source system, maybe that should have been called transform extracted load, TEL, maybe, is always done to some degree, but was historically kept to the absolute minimum to reduce source system impact. Transforming on an intermediate system, ETL, was then an obvious choice, minimizing impacts on both source and target systems. However, target systems, especially on the cloud, have little or no performance constraints, and the target relational DBMSs have good transformational abilities. So ELT makes a lot of sense. And yes, I do think they are complementary, and particularly an approach that combines ETL and ELT seems to me to be the most flexible and powerful one, especially if there's some intelligence and automation in choosing when and in what circumstances the function is pushed from the ETL server, where it is first defined and run, to the target system. So absolutely, not a question of choosing between the two of them. I think they can both coexist. And I think that's a really good approach. I mean, quality is central to all forms of decision-making based on data, or I would say more properly on information. So the first thing for me is always a thorough and quality data or information modeling job. I know that some people will throw up their hands and say, oh, too slow, too expensive. Let's do schema on read. But honestly, I don't think there is any other way to get high quality and highly consistent data in your warehouse other than modeling up front. So that's really important. And I think this modeling can and must be done in stages, an agile staged approach. That's a huge topic and one probably for another day. I know that many organizations have settled on fully dimensional data warehouse approaches. And that can be ideal for, I would say, up to mid-sized businesses. But for larger enterprises, some sort of consistent store of reconciled core data, an EDW, is generally preferable in order to create and maintain optimal quality data and information. So an EDW, I suppose, given my history, is an answer I would give. And then finally, beyond modeling, employing a good and flexible modeling team is probably the next most important aspect in implementing a top-class data preparation environment. And especially in mid-sized organizations, I would suggest that a data warehouse automation approach is probably best, both in terms of quality and cost, because typically that does include the modeling step in the process of moving forward. I think you'll need multiple pillars of data processing. I explained all that in my book, Business on Intelligence. So if you want to go dive deeper there, please do so. Some of these pillars will be traditional data warehouses. Others will be more like data lakes, but all will, of course, be fed with data pipelines, as I defined earlier in the interview. So key to all of that working well, of course, is to ensure that data in these pillars is well interconnected, related, and reconciled, as opposed to what we saw in traditional data silos. And what you call orchestration across the data pipelines is a key component in making this happen. Now, this brings us back to modeling, but also to metadata, because an essential element in orchestrating all these pipelines is metadata. Now, I prefer to call it context setting information, or CSI, because this word meta is getting a bit abused these days. Even Facebook have adopted it. So this kind of context setting information is what is contained and mentioned in Gartner's data fabric thinking, and is really this idea of it being active and actively maintained and kept internally consistent and aligned with changing business. Often Gartner suggests you need to use AI to do that. So there's getting this idea of active metadata involved is really important. My view is that we're actually quite far from this today, but we really do have to focus on it, because I think it's really going to either make this whole system work or it's going to fall apart. In architectural terms, my view is cloud is simply another storage pool, albeit huge and highly distributed. And if your data preparation tools support cloud sources and targets, then you're good to go, right? Well, I'd say not quite. It's cloud's distributed nature that you must first and always keep in mind. Data management was a lot simpler, I always say, when all your data was in a single mainframe. But copies of data are the bane of data governance. And the more places and the further apart these copies are, the tougher the challenge becomes. So the cloud enables and to some extent promotes data duplication, some of it largely invisible. So my first advice in terms of cloud is to beef up on your data governance and management teams because they're really going to be needed. The second consideration is what's called data gravity. Where does the data originate? If it comes from on-premises, there will be costs to lifting it up to the cloud. If it comes from the cloud, it's generally more effective to keep it there. Of course, most businesses today have data from both sources. So there's no single correct answer as to where to store and process your data. But clearly the pressure is on to get it onto the cloud, often for financial reasons. But here's the rub. The main thing here is to keep an eye on the relative costs of storage, processing, and data transport. And I think it's that last one that can catch you out, especially when we're talking about data preparation and data pipelines. Yeah, I think you're right. Everything now points towards automation. As I've already said, I mean, I'm a big proponent of automation in data and information preparation. That said, I'm deeply wary of automation in other areas, particularly where life-affecting decisions are being made. And I think we have to be careful about automation there. But back to data preparation, I think anything that reduces the cost of what is effectively just plumbing, right, is highly welcome. And automation should be applied at every stage of the process, wherever possible, from initial specification and design to daily operations and all the way through to ongoing maintenance and change management. So that's a very broad and very wide scope of what it is that we would need to do and what we need to automate. I just to throw in one caveat, based on my long years of experience, and that is that automation tends to push you towards predefined transformation function. And they're great, but the ability to create custom transformations that are unique to your own environment is often key to the in-house success of data preparation tools. So such needs may be only 5% or less than the transformations, but their importance is often easily underestimated because they're often the most important transformations from a business point of view. So in my view, data warehouse automation tools need to allow these sort of very specific transformation routines to be developed and embedded within the workflow.